right, so now let's see where were we at? Derivatives. All right, so I did power. That's it. Now I'm doing trig, which is secant x tangent x. So this is power trig, and now I need to do the derivative of what was inside the parentheses. So what's the derivative of x over 3? 1/3. So this looks like 2 secant squared tangent. Does that make sense? Mm-hmm. Thank you. What else? $34 and $35. Ooh. F of u, and instead of that, I'm just going to make it f of x and plug that in. So I got 1 over 1 minus x. Because it's 1 minus 1 over u, and it says u is 1 over 1 minus x. Y'all with me there? And then it says when x equals -1. Huh? They are, but all they're wanting you to do is plug this in for the u and find the derivative. Oh, no. So you're writing f of x, and then you're finding f prime of whatever value it gives you, and this says -1. So this is just a fraction and a fraction. I'm going to multiply by the reciprocal. This is going to be 1 minus x. I'm going to put it in top. One minus x. Because so I can keep the top the same and multiply by, and I flip that fraction. X minus 1 over 1. Yes. Okay. Let me write exactly what they have. F of u equals 1 minus 1 over u. And then it says u equals g of x, which equals 1 over 1 minus x. And then it says we're doing when x equals -1. So it says first, find f of g, let's do this, prime, when x is -1. Okay, that's essentially what I'm doing. So to do that, I'm first going to find f of g of x. Okay, and because g of x and u are the same thing, right? F of g of x is going to be 1 minus 1 over, and then instead of u, I'm putting in here. Okay. So I've got a complex fraction, right? When I have a fraction and a fraction, I do top times the flip of the bottom. You can't plug in the -1 until you find the derivative. You got to find the derivative first. All right, so I got 1 minus 1 times 1 minus x over 1. Which is 1 minus, this is over 1, so it's just itself 1 minus x. Oops. The ones cancel, that negative distributes, I just get x. F of g of x here is just x. Is it? I haven't done a derivative yet, right? I just composed it. That's all I did. So now what it asked me for, so now I know this, so I need the derivative of x evaluated when x equals 1. Well, what's the derivative of x? 1, right? Well, because this negative sign distributes, right? What are you plugging in? Yes, you plug in. There's nothing to plug in. It's a oh, here's -1. I see what you're saying. But there's nothing to plug into, right? Because the derivative f of g of x prime is 1. So it doesn't matter what I plug in for x. The derivative is always 1. It's a constant derivative because the function itself is linear. Sorry. Okay, so this is f of g of x, which is the same thing as this, right? It equals x. It said evaluate when x equals -1. Find the derivative when x is -1. Well, the problem is whenever I find the derivative here, there's nothing to plug in for x. Yes, if I had gotten that this was, I don't know, 5x squared, the derivative, and it said evaluate when x is -1, then I have something to plug into, right? But here, it's always, and that's because it's a linear function, and linears have a constant slope all the time. So the derivative is always the same. Sometimes the easiest ones trip y'all up because you think they're too easy. You don't think it's easy? And 35? So same song and dance here. F of u, I'm going to write it just like they have. Cotangent pi u over 10. And it says u is 5 root x. So I'm just going to replace this u with this 5 root x. Okay? Which is going to give me my f of g of x, right? Cotangent pi 5 root x over 10. Again, since I'm taking a derivative, I want to clean it up as much as I can before I actually take the derivative because it'll make my life a little easier. Cotangent 5 over 10 is going to be 1/2, right? So I've really got pi times the square root of x over 2. Now I'm going to take the derivative of this. Yikes. All right. There's no power, so outside first. Or trig first? What's the derivative of cotangent? I don't know that one off the top of my head. Negative what? Cosecant squared times, I got to chain it. So what's the derivative of this gobbledygook? So you might have to come off to the side to look at it, right? Because this is really pi over 2. That's just a coefficient times x to the 1/2. So what's the... So pi over 4, x to the negative 1/2, right? I got to multiply and subtract 1. By pi over 2. If I do 1/2 times pi over 2, top times top, bottom times bottom? No, it wasn't. It all starts to bleed together whenever you look at it so long. Now, that's not the answer because they asked me to evaluate it when x equals 1. Now remember before, whenever I got to this point, I didn't have an x in my equation, so there wasn't anything to plug in, but now I do. So now I got to go in and put a 1 in for all these x's. Y is what? You could write it like that, but you don't have to. I just pulled it out so I could multiply it by the power there. Because that pi over 2, x over 2 would be pi x over 4. When you're multiplying, it's different than when you're adding, because I would have to multiply. All right, so when I plug in, I'm going to assume this is probably a non-calculator problem because I'm at pi over 2's. This is square root of 1. I didn't write it so well. Cosecant is the flip of what? Sine. So sine of pi over 2 squared times pi over 4. What's, oh, yep, at pi over 2, I'm up at the very top, right? So the y value up at the very top is the y value up 1, right? So 1 and 1 squared, so I got negative 1 over 1 times pi over 4. So negative pi over 4. Cosecant is 1 over sine. Y'all do not like those trig functions there. You said 33? Let's just what? We can't just move on if y'all don't understand. I did not. I did. Oh. I've never heard students say limits were easy.
I got a 99 on limits and a 57 on that.
Oh my God. There are a few more left. I don't know if there's enough for everybody, but look, open that cabinet right there and look, they're sitting right there. It's not locked. See them?